Welcome to this explainer. Today we're diving straight into the fascinating mechanical realities of the workspace. We generally tend to think that more is always better, right? But have you ever wondered why simply adding more resources to a project doesn't always give you a proportional bump in your final output? In the real world of production, there are strict physical rules. So let's break down the science behind those limits and explore exactly what causes diminishing returns.
Picture this. You own a factory. You've got a set amount of machinery, and you decide it's time to ramp up production. As you bring on your first few workers, your total production skyrockets beautifully. But then, something weird happens. The extra output you get from each brand new worker mysteriously starts dropping. Why is that? Why doesn't the 10th worker add nearly as much value as the third one did?
Well, it all boils down to a core economic rule known as diminishing returns to a factor. Simply put, this is a situation where every additional unit of a variable factor, like a new hire, adds a lesser and lesser amount of output. In econ speak, we call that extra output per worker the marginal product. The fundamental law here dictates that if you keep cramming more of a variable input into a fixed environment, that marginal product is eventually going to fall.
To really get to the bottom of why this happens in the short run, we got to split our inputs into two distinct buckets. On one side, you have fixed factors. These are things you can't just change overnight. Think heavy machinery, the physical size of your plant, or major equipment. On the other side, we have variable factors. These are inputs that are super easy to dial up or down, primarily the workers you hire. The friction between these two, that's exactly where diminishing returns are born.
So let's get into cause one, disturbing the optimum proportion.
What does it actually mean to disturb that proportion? Well, in any setup, there is a perfect sweet spot for mixing your fixed and variable factors. Take a classic textbook example. Let's say the absolute best capital-to-labor ratio for a specific machine is exactly 1:5. That means one machine runs at absolute peak efficiency when operated by exactly 5 workers. That right there is your sweet spot. But here's the catch. If you go ahead and cram a 6th or 7th worker onto that single fixed machine, you completely break that perfect balance. The machine was already maxed out by the first 5. Since you can't just spawn a new machine in the short run, those new workers simply cannot be utilized efficiently. That imbalance leads directly to a drop in both the average product of your team and, crucially, the marginal product of those newest hires. And this translates perfectly to a graph. Notice the marginal product or MP curve in the lower panel. Right as we cross over into stage 2, that line just takes a nosedive. The peak right before that drop, that was our optimum proportion. Once we blow past it, the fixed factor is being totally overutilized. The balance is shattered and diminishing returns officially set in. Moving right along to cause 2, imperfect substitutability of factors.
This one is grounded in plain physical reality. Inputs simply cannot perfectly replace each other forever. Think about it practically. Up to a certain point, sure, you can hire extra workers instead of buying a new machine. Maybe they handle some tasks manually. But there is a hard limit to this. You absolutely cannot permanently substitute human labor for a missing machine. People aren't just gears in a conveyor belt, right? Because they aren't perfect substitutes, those diminishing returns are inevitable.
And if you stubbornly ignore those physical limits and just keep throwing more people at the factory floor, you don't just get diminishing returns, you crash right into stage 3, which is outright negative returns. Why does that happen? First, overcrowding. You've got way too much labor on a fixed amount of equipment. Second, there are fewer tools to go around. Third, workers literally start getting in each other's way, bumping elbows. And finally, total management chaos. It is impossible to run that many people in a constrained space, which causes your total production to actually shrink.
Which leads us directly to the rational producer's choice.
Knowing all these physical constraints, how does a smart business owner navigate them to succeed? Well, let's break down the 3 stages of production. A rational producer completely avoids stage I. Why? Because in stage I, the average efficiency per worker is still climbing. Stopping early means leaving money on the table. You'd miss out on that increasing efficiency. And they definitely avoid stage 3. I mean, stage 3 is considered economic absurdity. The marginal product is literally negative. You are basically paying an additional worker to lower your total output. No way.
So, just by a simple process of elimination, a rational producer actively chooses to operate entirely within stage 2. In this middle stage, your total product is still growing, even if it's growing at a slower, diminishing rate.
The rational producer accepts the physical reality of diminishing returns, but they stay in this stage to squeeze out the absolute maximum total output, right up until that marginal product hits zero. So as we wrap up this explainer, I've got a question for you to think about. When you analyze your own business, your team, or even your personal side projects, ask yourself, how close are you to your optimum proportion? Are you operating right in your sweet spot, maximizing those fixed resources, or are you simply throwing more variable effort into an overcrowded system, just waiting for those inevitable diminishing returns to kick in? It is absolutely a vital question to answer if you want to produce at your best.